Welcome to NUVIZ's Prepare, Plan, Design, Implement, Operate, and Optimize NUVIZ data center platform, designed specifically for managing a complex infrastructure. What you see in front of you is the GPS coordinates location and data relying specifically on the coordinates of the device and the data center. You are also capable of actually creating the 3D floor plan builder, which allows you to create a complex infrastructure data center where the operator can navigate from one building to another built into different building locations. This gives the operator the luxury of seeing the data in a lot more comprehensive detail and visual awareness of the entire schematics of the data centers. Operators will have the capability to navigate and jump from one data center to another. It will give you the ability to view the inside of the rack, understand the rack, digital visualization, a digital twin of the rack, power, PDU consumptions, routers, devices, and a lot of different complex infrastructure network elements, which are typically not seen by the network design documents. What you see in the front of you also can navigate through the devices directly through that caption, and you see the elements of the data center elements that will allow you comprehensively to create accomplished navigation and allow the operator network design and visualization person who is responsible for building the data center, operate data center, and understanding the data center schematics. This is designed also for the heat map. The heat map tracking is designed specifically to allow the users to understand the pitfall locations and complex capability of the infrastructure of the data center. The heat map is designed for the operator to quickly identify the weak areas and create a more comprehensive visualization, understanding how these heat maps use the operator's detailed view of understanding the weaknesses of the data centers. The orange represents, and yellow represents, and red represents alarm warning, and green represents that conditions are fine. So what you see is also a transparent view calculation. A transparent view is designed specifically to allow the operator to understand the capacity planning for the data center, allows the operator to understand how much capacity is left in the rack, and gives you the open capability to understand what's inside of the rack. And then once the design is done of the data center, you can go to a floor builder. The floor builder is designed specifically for the operator to reduce the complexity and allow the operator to create a simple navigation point drag and drop where you will put the maximum power consumption and resources, which will help the user and operator understand how much capacity we'll be allocating to this particular data center. This floor builder is designed to allow the operator to click and point directly and drag and drop that directly into the floor builder. The floor builder has a way to do it multi-floor and allows you to do multiple different data centers. The discovery element is designed specifically for the operator to discover the complex networks. You can specify the ranges and you will identify the system automatically with Discover. It usually takes several different hours. If the network is large, thousands to 2,000, it can take about 3 to 4 hours to discover. Once the devices are discovered, they get installed into the database. Inside the database, automatically identify the device kind, provide the restore, provide that, interfaces, providing a visual topology service topology so that product can navigate directly into the network of interest. The system will allow you to create a service topology that will take you directly to the point of interest of each device. Each device holds the legend and different information and also creates a capability to go into the tracking. When you select each device, the tracking will automatically create and put it into the monitoring section, which we'll show a little bit further in this demo. We're also using a complex legend system where you can interact with the interfaces. You can filter routing, you can provide directly connected BGP, and the capability to see the network topology awareness. Network topology is designed for service networking, the architects to understand the dependency and interaction so they can correlate the physical domain and logical domain. You also see the capability of the intelligent legend. This intelligent legend gives you the ability to navigate directly into the point of interest for troubleshooting the network. Rack Builder also gives you the ability to design the network after discovery is completed. You can simply find the point of interest of your device, drag it and drop and specify the stencil and name, and now automatically the system will detect the power consumption for the stencil because it was pre-provisioned before. So the new NUVIZ is designed specifically for the operator to create a calculation for consumption. We also have the direct capability of going inside the device and doing discovery devices. By discovering devices, we automatically install an automation for simplification of the complexity. We install all the modules, line cards, GBIC, and any devices that are sitting installed in the device will be automatically propagated. It will create a dynamic stencil so the operator can navigate inside the system. Moving forward, what you can see is automatically all the devices are installed inside of the chassis and the stencils are provided for you. After you do the restoration of the discovery a second time, we automatically propagate all the discovery devices. So when you discover the stencil will keep the information, the port density. Also, information on the devices is connected with a port information source and host destination, which means the direct builder will have information not just as chassis, not just the line card, which you see in front of you, but it also has the capability of understanding the relationship and correlation between interfaces, line cards, and the relationship directly into that line card that you're trying to correlate. So it gives simplification for the user so the human doesn't have to correlate the interface port to the module to the line card. Once you go into the tracking device after the design is done, the tracking components are responsible for creating a different component. We can do CPU, memory usage, power consumption, temperature, and all these things that will happen automatically as soon as you set the threshold. At that threshold, you can select the interface by directional bandwidth, and it will give you the power consumption. If you set the threshold as how frequently you want to pull, the tracking becomes out your intelligent element that collects the information. Once the tracking is active, we go into the start tracking, and the start tracking will start collecting information directly into his behavior and power consumption, and then the fly will generate the dashboard. The dashboard will provide you the status of reports activity on each tracker so that the system is embedded inside of the newness reporting. So digital twin replica of the rack will have all installation devices. You'll see the face of that in the text format. You'll see the rack also in the visual stencils, and it will allow the operator to navigate directly from rack to rack. You can also put racks side by side to do comparisons, verify the modules, and have a full value of understanding how the stencils are configured. So you can create a side-by-side cloning capability if you like to do so. Also, on the left side, you see automatically each of the stencils has the power consumption already pre-provisioned. So the operator can navigate directly into each individual line cart. And then after this, you will be navigated to the inventory. Inventory design racks, rows, data center, cities, and countries. Everything inside the inventory asset management is connected to the warehouse, which means no devices are missed. No elements are missed. Everything has been discovered. The design goes into the warehouse. It also installs the devices, so the system automatically detects the position where everything is installed, providing IP address, SILI code, serial numbers, device type, location, description, GPS coordinates, and anything that is required to identify. A big component of the NUVIZ also is a diagram editor. Diagram editor is designed to replace the new Visio component, which allows the single system to have a one navigation tool where the operator can take advantage of actually designing and creating completely A to Z the diagrams that allow the operator in one single platform create a component of the Visio-like diagram. Another big element component of the NUVIZ is cable management. The cable management element is extremely important for the people who do rack and stack and for people who do the layout. So what you see on the left side, the source and destination, the system after discovery, will allow you to provision directly to devices and automatically pre-provision the source and destination and select the batch panels that are correlated to specific interfaces. So CDP Cisco Discovery Protocol connects it on the left side, discovers the port, and then you put a description that connects and allows the operator to provision A to Z from point A to point B, and then it will give you connect. And once the connect devices, you will see the correlation across the entire board. As soon as it becomes red, that means the port is provisioned, and it's only available for a specific device. The provisioning is done specifically. Also, automatically calculation of on the bottom that you see that, the length of the distance from point A to point B, and you see the stencils of the visual representation of the rack. You see the connection cable, you see in, patch panel out. So the cable management component is extremely valuable for the users to manage the source and destination. You can also have the capability to connect across multiple data centers. So it's not among someone not on a single floor. A single floor capability is a very common tool that is available. But now in NUVIZ, it takes it to the next level by creating also the same capability across multiple different floors. So you cross-connect the cable management between floor 1 and floor 2, or create the connection data center cabling fiber optic between two separate data centers not physically located in the same environment. This will give you the capability to see the full schematics of visualization, of understanding how the data center is provisioned, how the data center is connected cable-wise, and provision exactly the capability where the data starts and ends. Asset management inventory is designed specifically where everything that goes inside of the data center is installed, discovered, and goes into a centralized database where the user can find the serial numbers, can find connections, and can also see the cable length applied to the interfaces. You'll see also the MAC address, IP address, line card, and anything that's related. Another very important element of the new module is call port management. Port management is designed specifically to track unused devices. These unused devices are designed specifically to allow the data center to prevent and utilize ports to prevent wasting a lot of energy and resource consumption. So what you see in the front of you is that a component of the new VIS can monitor port management. You could see which vendors are connected. So every time you're monitoring the port, you will understand that the port is active. You'll see what's connected to it, which MAC address, and which vendor is connected to it. You also have the luxury to actually suspend the port and monitor the port activity to see it when the last time the port was used. These components, or port management, extremely is important for monitoring the devices and monitoring the activity of the port. So you don't have the port activity active for no reason for the unused situation. So we also can sort it out based on state. We can sort it out based on our locations, and each individual state can have the independent devices installed. You can also have the sites by leveraging the site by Silico. The Silico plays a role in the telco environment. Then you can search it by how many active days the interfaces are not active. These are components that are really important to basically save energy consumption and suspend the ports that are no longer used. And these types of ports are important for managing. If they're 90 days, 60 days, or 30 days unused, you might want to suspend them, because if you don't suspend the interface ports, the continued changing of the charge electricity consumption will be extremely damaging to the billing to electricity. We're also providing a device report. The device report creates a full capacity of the capability based on different statuses on an up or down, or we can look at the status that is sorted out based on MAC to IP. MAC to IP plays a role, so you know which MAC address is tied to which IP address. This is extremely important for navigation to understand which IP address is assigned to each MAC address. We use the ARP table, we use an IP driver, we use a bridge map, we collect information directly so we understand the neighbor relationship. We understand the discovery component of which individual device is connected. Once we also have the scheduler system. In the scheduler system, you can put it and schedule based on demand, so you can get data on a specific date, specific time, based on the Silico, based on the range, and based on the specific device scheduling system. Automatically, when the schedule happens, it goes into the tracker system. We also have a comprehensive dashboard. It shows the inactive ports and it shows the active ports, and it shows the status of the widgets of information on how frequently those ports are used, the percentage of the data center that is not used up, and what's the percentage of interface they're up, and what percentage interface is down. You could select this by silicones. You can look at the base by location. Each dashboard ties to a specific location based on GPS coordinates, and everyone has their specific dashboard based on size. You also see the MAC vendor, location, total number of down interfaces, and selection of the aggregation of the down interfaces and up interfaces all in one single dashboard. Thank you very much.